this is yeah, using coiled SLURM-like job arrays for rechunking. And this is something that I saw pop up in this cool coiled blog post. And we had been using SLURM on our HPC systems when I was working at USGS for doing rechunking. So I thought it'd be cool just to see how I could do it with coiled. And he makes this little comment here. If you don't know what SLURM is, actually, it's what most people use to submit jobs on HPC systems and also cloud-based HPC like Parallel Cluster and Cycle Cloud and stuff have SLURM-like things where you can submit jobs. And of course, on HPC, it takes care of your job and queues it up and everything. On the cloud, there's really no queue, but it's still helpful to have this kind of syntax. And so really what we do, this is the way we were doing it on HPC. If we have a whole bunch of netcdf files and we want to rechunk them, we would basically take some collection of netcdf files and on a single node create a ZAR using rechunker. Sometimes we'd convert that ZAR actually back to netcdf using a xbitinfo helper function, right, to compress netcdf. But either way, even if you just go to ZAR, you end up with all these rechunked ZAR data sets that then you can use something like Kerchunk, or hopefully in the near future, if it isn't there already in virtually ZAR, to create a virtual ZAR data set. So, and the way this works is you submit this single script, and each of these jobs gets a task ID from SLURM. So this is a job array in SLURM job array. So each of these tasks gets a number, and that number then can be used to process, say, the first 4 files, and this one process this number 2, process the second 4. And so you can just submit this, and each of these will run on different nodes, so they can use like rechunker with local cluster or whatever. Like with ZAR v3, I guess you could just use all the CPUs on that particular node to do your rechunking. And then you have this next level of parallelization that is independent machines each doing these chunks, which of course gives you the huge throughput if you run into a single machine IO limit or something like that. So obviously we're not doing 12 files, we're doing like often we're doing like hundreds of thousands of files. So I have this little repo here that just shows how I did it. I'm just going to show you just real briefly so you have the idea. So all you really do is you install Coiled, and you say Coiled batch run some script, and the script looks like something like this. In the script itself, you have these things where you just say, how much disk space you want, how many tasks you want, blah, 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 where you're running it, so on, what kind of machine you're running it on, what kind of size machine, and then in this case, my Amazon credentials, because I'm going to write out, obviously, the rechunk data to S3. So if I just go back, I ran this huge, era 5 rechunking workflow on 19 processors. Each had, I think, I'd have to go back and look, like I had 36 CPUs. It cost $13, and it was done in 26 minutes. And and I was actually rechunking from the entire spatial domain where it sits on Google Cloud to like a 20 by 20 in space, and a huge amount in time, because I wanted to extract time series quickly. And and here's just a demonstration of it working. I just go some latitude longitude point, this Cape Cod, and load the whole thing with like no extra CPUs or anything in 4 seconds, because we're just loading a few chunks. And here's the the full time series. So uh actually, I think that's yeah, that's it. So we have some time for questions. Oh,